Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're covering the topic of the mathematical analysis of the mirrors. So in the previous lesson, we will cover the topic of the ray diagrams. We have made the ray diagrams, and I told you that ray diagrams are very easy to make if you know the mathematical analysis of the mirrors. So for this, you have to know about some things like some formulas which are on your formula sheet and some sign convention, which is very important. So that makes the mathematical analysis very tricky or very difficult, but not very difficult if you know the sign conventions. So sign conventions are all the core thing of this lesson. So this will make your ray diagrams very easy, but you not actually make diagrams, but in the MCQs, for sometimes you have to make that diagram for your perspective to answer the questions. That way questions you get, and it is about that like that. So firstly, you have to know about the mirror equation. That mirror equation, that this lesson is exactly same as the lesson we do with upcoming lesson with the lenses, because mirror is the topic and we do the lenses too. That all things, same things you will use in the lenses. But we do now the mathematics for mirrors. So we have a mirror equation. So this is the mirror equation. 1 do plus 1 upon di is equal to 1 upon f. So what is that? This is the mirror equation. This is in your formula sheet. And that do, which is that do. This is do is the object distance. O means object, d means distance. Distance of the object from the mirror. This is from the mirror, and whenever your project is over there, this is at distance. Di is your distance of the image from the mirror, which is I is image. So this is distance of the image from the mirror. F is your focal length of the mirror. What is that focal length? Like F and that mirror, that between distance, what is that distance? That is called the focal length. And you have a secondary equation for supporting the, if you have the something about the image. You have DODI, but you don't have, like, you have to use, you have to something, you have to find something else. We have something else for the image. So for that thing, you have the images too. So height in explain to height. The distance is also compared to height now. So hi upon ho is equal to minus di upon do. The di and do stays the same, distance from the object, distance from the image to the mirror. Hi is your height of the image, ho is your height of the object. This is also in your formula sheet. So if you have like di do and you have to find with the ho, you have to find. So hi is, you have to find h is 72. So that's all we're going to do with the heights of the image or object. So these all the breakdown that where your DODI is located. So this all the things you have to know. So here's your DO, which is distance of the object, distance of the image, height of the image, height of the object, and this is your focal length from the focal point to the vertex of the mirror. Sign convention, very important. So that table you have to memorize. That whole table you have to memorize. There's only two possibilities for signs. They either be positive or the negative. For positive, if your di, which is the distance of the image from the mirror, is positive, so you get the real image. If your di is negative, you get the virtual image. If your focal length is positive, you have a concave mirror. You can directly say that this is a concave mirror. If your focal length is the negative, you can directly say this is a convex mirror. With di, you can say that what type of image is. With f, you can say what type of mirror is that. With hi, you will see that what orientation, what type of thing you have, what type of orientation they have. They are inverted, they are diminished, there are two possibilities, inverted or the upright. If hi is positive, you get the upright image. If hi is negative, you get the inverted image. So if you know this, you can do the mathematical analysis very easy with the questions. With this examples related to this. And your do, which is object. Object is always positive, as the object is real. Object is always real, so it's always positive. So do is always positive. Hi is majorly related to the orientation of the object. So if hi is greater than 0, image and object has the same orientation if hi is greater than 0. If hi is less than 0, this means an image and object have an opposite orientation. So if you know this, like if your hi is greater than 0, so same orientation. If less than 0, so you have to do something because they both have opposite orientation now. Note that the sign of hi has nothing to do with the whether image is real or virtual, because hi and di is very different things. Di will give you a distance and hi will give you the height. So this is the thing that if you have hi and you don't have di, so hi can't tell you about nothing about the real or virtual. Real or virtual only tell when you have the di. So you have to find the di with hi or find the hi with di to do the things. So the formula is yours. Formula is a formula sheet. So do something to that the things. One more thing, we discussed the topic of magnification, and the magnification is equal to the secondary equation. So magnification is denoted by m is equal to hi upon ho is equal to minus di upon do given in your formula sheet. So that whole formula is equal to m. If you have to do something with hi upon ho and with m, so you can use this part of formula. If you do with something with this, you can use this. If you with this and this, you can do this. So anything you do, three of them are equal, so you can use any of the three things. But the mirror equation is separated. There is no connectivity with this. Okay, the magnification is called the magnification. What type of image this? Diminish, enlarge, same size. The magnification work for this. Okay, so if m is, which is magnification, is greater than 0, you will get an upright image. Less than 0, you will get an inverted image. Like if you don't have hi, you have a magnification. So for the with the help of magnification, you can also tell the what type of image. You have upright image, you have inverted image. Same thing, greater than 0, you have upright image, less than 0. So you get it. These three things. If the m is less than 1, you will get a diminished image, smaller image. If m is equal to 1, you get the same size image. Image size is same as object. No change. If m is greater than 1, you will get the very enlarged image, which is larger than the object. So with the magnification, you get this. So this thing, and the two formulas are in your formula sheet. So these two slides you have to memorize because these are all about the sign conventions and the stuff you have to know for the making the ray diagrams or doing the questions of the mathematical analysis. Note that the negative sign is required in above equation for the magnification to be consistent with our sign conventions. The negative sign should be important. The negative sign should not be skipped. This is formula's negative sign. So you have to use that. So okay, so example for this to more clarity of this topic. So firstly, when you read the question, you will see more of the things with this. So what that those things? The object is placed 20.0 centimeter in front of a convex mirror. So we will see that there is a convex mirror. So if we have a convex mirror, so what type of what the focal length will give you? This will tell you that the f is less than 0. This means you have a negative thing. You have a negative focal length if there is a convex mirror. And what tell about this? The object is placed 20.0 centimeter in front of the convex mirror. This is about the distance. So this is your DO. Next thing, the focal length is given to you, which is 10.0 centimeters. So but shade, this should be in negative 10.0 centimeters. So make this F. To determine the image distance and the magnification, all you have to tell if the image is real or virtual. So basically you have to find the m and image distance, which is di. So you have do, you have focal length, and you have to find the di. So easily find with the mirror equation. We tell 1 upon f is equal to 1 upon do plus 1 upon di. You have to find the di. Isolate the di from this. You will get 1 upon f minus 1 upon do. So make the things in this. So f is minus, so put it in minus. Minus do is 20.0 centimeter. This always been positive. Make sure your centimeters are like units are same. If one of the difference, you have to change that. So you can solve this, divide this and minus this, and you will get something like this: 1 upon minus 0.150 centimeters. But you will do this in your math, that if you have the reciprocal of this, if you put over there, you will, what do you get? You will get a negative 1 sign like this. You do this in your math. I think you do this. So, do you do this? And with di, if the minus goes over there, you will get a di is equal to this thing. And you have to solve this now. When you solve this, you get minus 6.666, repeat in centimeters. You get di negative. Which that means you have a virtual image. And you always have the virtual image in the convex mirror. This is a quick check of this. But sometimes you get this color with the concave mirror. And you also find the magnification. So you have di, you have do. So you can use this part of thing, that this is equal to minus di upon do. So minus is a formula, and then minus 6.666 centimeters. Divide this by 20.0 centimeters. You will get your m of about 0.333 centimeters. No. So make sure that I didn't tell you that the magnification has not any units. So magnification is unitless quantity. So your magnification is about 0.333. So this is your di, this is a virtual image, and this is your magnification. So this di is not like this. Wait. So di is equal to 6.67. It's my mistake. This is the answer. Not this one. Yeah? So next question. This is from the diploma question. I picked that question because this is very nice structured question, and this will test you for the number of things for the analysis of mathematical. So this front of concave mirror now. So the object is placed in front of concave mirror, which means that now your focal length is greater than 0, which is positive. Focal length of the mirror is 15.0 centimeter, which remains 15.0 because this is positive. Then, and the image is magnified by a factor of minus 1.50. So magnified to this means your magnification is given. But also this is a unitless quantity. So there is only one unitless quantity in your whole mathematical analysis. So this is your m. You have to determine the distance of the object from the mirror. So basically you have to find the do, which you get in positive, because do is always in positive. That is from there. So what you have to do? You have to find the do. Do is find from the 1 upon f is equal to 1 upon do plus 1 upon di. But you don't have like do in this. And you don't have di too. So you have to do something to get the di. F you have, and you get the do. What you have to do? You have a magnification given to you. So let's do with something with magnification. So magnification is the so you don't have like height anymore. You don't have a height in all this, height of image or height of object. So this magnification is equal to minus di upon do. Okay, so you have magnification which is 1.50. You don't have di and du. This minus and this minus cancel out. This is minus 1.50, and you get 1.50 is equal to di upon du. If you do cross multiplication with this, you get di is equal to 1.50 du. So di is equal to this. If you put this then in this di, you will get something. stays focal length same. DO is not given to you. You have to find this. Plus DI is 1.50 DO. So you do this thing in your math that you get the common denominator. So they both are DO, so you have to multiply this by 1.50. This also multiply by 1.50. So when you do this, you get this 1.50 plus 1 upon 1.50 DO. Now this thing is equal to this plus this, so you get 2.50 upon 1.50 DO. So if this is 1 upon f is 2.50 upon 1.50 DO, so now if you want like flip the f, reciprocal of f, so you get f, and you also do the flip of the reciprocal of the right hand side too, because if one is like reciprocal, the other things also be reciprocal. So you get 1.50 DO upon 2.50, and you have to isolate the DO from this. So this f is equal to 15.0 centimeter now, and this goes over there, which is 2.50, and this whole thing we divided by 1.50, which is equal to DO. You multiply out, you divide this by 1.50, and you will get 25.0 centimeters, 3 sidhits, and you get in positive, which is your TO. So this is your answer for TO. So that's all work you have to do, that extra work you have to do in this to get to know about this question. So that's all you have. That's why it's the diploma question, because lots of things you have to know in this, the different things. So that's all for this lesson. We will know about the mathematical analysis, and now we like done the reflection part. Now we move on to the reflection part, which is related to the lenses. Lenses we do like some topics, some lessons after, but the lenses part we do in as soon as possible when we move on to that unit. So language and EduVibe, learn smarter for not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Kill this negative with EduVibe.